Hello, this is Mr. Huber. In this lesson, we're going to learn about solving one-step equations. Solving equations is very fundamental to algebra and lots of math beyond that. So let's learn some of the basics here that we can use to build on for these equations and many more. The key to solving one-step equations is to get a variable by itself. We're going to do that using inverse operations. Okay, inverse, think opposites. Okay, so inverse operations undo each other. So examples would be addition, and the opposite of that would be subtraction. Okay, addition and subtraction are inverse operations. Division and multiplication are inverse operations. Okay, they undo each other in equations, as we're going to see. So keep that in mind when we're trying to get a variable by itself. We're going to do using inverse operations. When we solve these equations, we want to isolate the variable, as I was mentioning, right? Isolate the variable. And we're going to do that using inverse operations on both sides of the equation. Because when we're solving an equation, we have to keep in mind that whatever we do to one side of the equation, we need to do the same on the other side. We're doing those inverse operations. That's how we'll keep the equation balanced and equal on both sides. Think of it like a scale, right? If we have a scale like this, whatever's on one side, we want to keep balanced with the other side. If I add more weight over here, this side will drop down, this would raise up, and they won't be balanced and equal to each other anymore. But if I add a weight on this side and the same amount of weight on this side, it will stay balanced out. So keep that in mind when we're solving an equation. That would be like having an equation here, x plus 7 equals 10. Okay? The balance here is our equal sign. And we want to make sure that these two are always equal to each other. So whatever we do to one side of the equation, we're going to do the same thing to the other side of the equation. We're looking at those inverse operations. And those are called properties of equality. When we do the same thing to both sides of the equation, those are called properties of equality because they're properties that keep equality in this statement we have, this equation we have. Also keep in mind when we solve these equations, we're going to be able to check our answers. That's a great thing. You're going to be able to check and see if you got something correct all on your own. Right? We can use that by substitution. Remember, we can substitute a value in for a variable to see if it makes a statement true. So when we solve an equation, we're going to see if that solution we got makes the statement that we started with true. Let's try some out. We want to be able to identify which side of the equation the variable's on, and that's where we're going to look to show our work with our inverse operations. So if we have x plus 7 equals 4, identify the variable right over here. Okay? We don't even care what's on the other side of the equal sign. All we care about is the side with the variable right now. We have x plus 7. This is where we want to use inverse operations. The goal is to get this x as the only thing by itself on one side of the equal sign. And remember, this is like our balance here. Right? So we have our balance. So we need to keep things balanced on both sides. If we do an inverse operation, minus 7, because that's the opposite of adding 7, right? The opposite of this addition is subtraction. And so if I subtract 7 on both sides, I will get x plus 0 equals negative 3. X plus 0 is just x equals negative 3. That's my solution. X equals negative 3. I got the variable by itself because adding 0 to something keeps it what it already was. So we're going to have x equals negative 3, which we can check. We can take that negative 3, okay, and we can plug it back into the original equation. Always go back to your original equation. And so we're going to check by substituting a negative 3 in for x plus 7 equals 4. This will give me 4 equals 4. That means that is a solution. It made the statement true. So I know that x equals negative 3 is a correct solution. We can check that every time. You should show your work and check your answers all the time. In this next equation, we've got n minus 12 equals 3. So identify the variable on the left side. We're going to add 12 because that's the inverse of the subtracting 12. When those cancel out, and I'm not always going to write down n plus 0. We should get used to the fact that this n plus 0 just gives me the n by itself. And then 3 plus 12 is 15. So n equals 15. And we could check that. We do 15 minus 12 equals 3. That's 3 equals 3. That worked, and I know that n equals 15 is the correct solution. In the next example, again, we don't want to just start on the left side. These first two equations, we started on the left side because that's where the variable was. Equation, variable on the left side. Equation, variable on the left side. Equation, variable on the right side. So we want to look over here and say, okay, I'm trying to get this w by itself. Always take the sign in front of this number. This is a positive 3. We cancel out a positive 3 by subtracting 3. 3 minus 3. That cancels out. We're going to get 6 equals w, and I can check that. 9 equals 3 plus 6. That gives me 9 equals 9. That worked. I know that w equals 6 is a correct solution. Okay. Show the steps, use the inverse operations to get that variable by itself, and then always check those answers. All right. If we look at this next example here, okay, we've got negative 6y equals 48. So negative 6y equals 48. I want to look for the variable, the y, and say, what am I doing to that y? Well, I'm multiplying it by negative 6. Right, we have to identify the operation that's happening to the variable. So the way I'm going to cancel that out is to divide by negative 6. The inverse of multiplication is division. And negative 6 divided by negative 6 is a positive 1y equals 48 divided by negative 6, which is negative 8. That's 1y. 1y is what we want to have, right? We don't have to write the coefficient in front of that variable. We say y equals negative 8. Okay? So that's our solution, which we can check. I'm going to check that by plugging it back into the original equation. Negative 6 times negative 8 equals 48. Okay? And we're going to get 48 equals 48, which is true. So y equals negative 8 would be my correct solution. Okay, another one coming up. We have 5 equals x over 4. And again, pause, try these on your own as you're getting comfortable with them, see how you're doing and seeing if you're getting them right. So in this equation, we have x divided by 4. So inverse, find the variable. What's happening to the variable? Dividing by 4. What's the inverse of that? Multiplying by 4. So I'm going to do the same thing on both sides of the equal sign. It's going to be 20 equals, this is like 4 over 1. Well, that's why that works, so the 4's will cancel and just give me x. X equals 20. I can check that. 5 equals 20 over 4 gives me 5 equals 5, which is true. So x equals 20 would be my solution. In number 6, we have 30 equals negative 5 plus m. Right. I'm going to show you here a mistake. Let's say I said, oh, this is a plus sign. So I have a positive here. Oh, I want to cancel out addition by subtracting. So I'm going to subtract 5 on both sides. So I subtract 5, I get 20 equals m, or 25, excuse me, equals m. So 25 equals m. Now if I check that, okay, I can check that. I would plug the 25 back in. I get 30 equals negative 5 plus 25. That'd be 30 equals 20. That's not true. So that must not have been my solution because I should have added 5 to both sides. There's a sign here in front of the negative 5. That's a negative. How do we cancel out a negative? If I do negative 5 minus 5, I actually should have a negative 10 over here with the m still. That wouldn't cancel out. But if I add 5 to both sides, now that cancels out. So I would get 35 equals m. I plug that in, that will work. That's why checking can be useful. I checked here. I saw that my answer didn't work. I go back up and I can identify, oh, I was supposed to add instead of subtract. You can fix that, then check it, and see that you got it right. So make sure doing those inverse operations, get the variable by itself. When you find the value of a variable, plug it in, make sure it works back in the original equation that you were trying to solve. We'll try some more examples here in a moment, but first, a bolt of brilliance. And I'm sure you guys are all brilliant, so what can we do with that knowledge and figure out what's 5 times hotter than the sun? The sun's pretty blazing hot out there in the sky, but something 5 times hotter than that is a bolt of lightning. Yes, a lightning strike has heat 5 times more than the sun. All right. Let's try out some more problems. Again, you can be trying these as we go. Pause the video, practice them, and see how you're doing. So in this next example, number 7, negative 8 times n. So the inverse of that would be dividing by negative 8. And I would have 3 equals n. Keep track of your negatives. We have a negative divided by a negative. That gives us a positive, right? This is like a positive 1n. We don't want to divide by positive 8. Negative divided by positive 8 would give me negative 1n. I don't want to have negative 1n. I want to have 1n equals, in this case, 3. And I can check that. Okay, I would have negative 24 equals negative 8 times 3. Negative 24 equals negative 24. That works, and I know I got that right. Okay, another example here. Negative z over 2. Okay, we need to multiply this by negative 2 because, again, we need the negative times the negative. Negative signs are often going to be where you're making mistakes, so pay particular attention to those. So we'd have negative 2, that's like negative 2 over 1. So those cancel out to give me a positive 1z. And on this side, I'm going to do negative 2 times 13, negative 26. Okay, and I can check that. Negative 26 over 2 would be a positive 13. All right, you should be checking those for the sake of time here. I'm going to skip that step on a couple of these, but you should be doing that. Times 5 to cancel out the a equals, multiply by 5 on both sides, negative 55. We can check that and we'd see that it works. As we look at these next equations, there's some fraction work. We're going to have to keep in mind what to do when we're dividing by a fraction, how we multiply fractions as well. So if we remember that 2/3 divided by 5/6, let's say, is the same as 2/3 times 6 over 5. Right? When we're dividing by a fraction, that's the same as multiplying by its reciprocal. So we're going to keep that in mind down here when we have 5/6 times w. Right? To cancel out that multiplication, we're going to want to use division. Well, dividing by 5/6 is the same as multiplying by 6 over 5. And we're going to do that on both sides of the equal sign. Because when we multiply reciprocals here, 6 over 5 times 5 over 6, that will cancel out to 1. The 6 is reduced to 1 and 1. The 5 is reduced to 1 and 1. We have 1 over 1, which is just 1w. And now on this side, we have to cancel out and simplify the 5, 1, and the 10, which is 2. And we're going to get 2 times 6, which is 12 over 1, which would just be 12. And we could check that, right? We can plug that back in. 5 over 6 times 12 over 1 equals 10. And that would be a 1 and a 2. 5 times 2 would be 10 equals 10. That checks out. And I know that w equals 12 is a correct solution. So when we're canceling out the dividing by a fraction here, remember that's multiplying by its reciprocal. So when I go over here and look for my variable, it's on the right side. I have negative 3/4. I want to multiply by negative 4 over 3. Right? Multiply by a reciprocal to cancel out that fraction. That would be a negative. Times a negative would give me a positive. Negative 4 over 3 times negative 3 over 4 becomes a 1, positive 1. And now I have to do times negative 4 over 3. Right? Keeping track of those negative signs in your fraction work. So the 3 would be a 1 and 3. 4 times 3 is 12, and I'd get negative 12 equals m. And I could plug that back in to my original equation and see that it works. So remember, to cancel out a fraction coefficient, when you're multiplying the variable by a fraction, multiply by its reciprocal of that fraction, and you'll cancel it out and get the variable by itself. Let's look at an example here, how we can apply this. So we have Sean Crawford, who ran the 200-meter dash in 19.79 seconds. We want to find his average speed, and we're given an equation here that we can use. Distance, well, his distance was 200 meters. Equals rate, that's the average speed, that's our rate. That's what we're trying to find. I'm just going to put an R for rate. And his time, 19.79 seconds. So where's my variable? It's on the right side, the R, the rate I'm trying to find. I can divide by 19.79 on both sides. So I divide by 19.79, divide by 19.79. And I have 200 divided by 19.79, which comes out to 10.1 meters per second. That's a rate. 10.1 meters per second, a speed, like miles per hour, right? Distance per time. So we found the average speed by filling in the information we have and solving for a variable, right? You solve this equation for the R just like we would any other time. R times 19.79, use inverse operations. Find the variable, do the inverse operation to isolate that variable by itself, and you can always check that answer by substituting the value into the original equation and making sure that it works.